Intro. For thousands of years it's been one of the world's great mysteries. Just how were the pyramids built so deep in the Egyptian desert? Now scientists say they have the answer. They found evidence of a branch of the Nile. The Great Pyramids of Giza, ancient tombs or advanced technology? For over 4,500 years, the Great Pyramids of Giza have stood as towering testaments to human ingenuity, guarding their secrets while captivating countless minds. Were they merely elaborate tombs for pharaohs? Or did they serve a far greater purpose? Some theorists argue that these pyramids were more than just architectural wonders. They may have functioned as ancient power sources, harnessing energy in ways we have yet to fully understand. Now, thanks to cutting-edge AI technology, researchers may be on the verge of uncovering the truth. Could the pyramids represent a lost technological marvel? Or is there an even deeper mystery waiting to be revealed? Decoding the Giza Plateau. Traditional historical accounts date the understanding of the Giza Plateau pyramids' construction to Egypt's Old Kingdom, particularly the 4th dynasty circa 2600 to 2500 BCE. During this period, Pharaoh Khufu commissioned what is now known as the Great Pyramid, followed by his successors Khafre and Menkaure, who built their own pyramids nearby. Together, these structures formed the iconic trio we recognize today. Each pyramid was part of a larger complex featuring mortuary temples, causeways, valley temples near the Nile, smaller satellite pyramids and supporting structures. Ancient inscriptions and records from other Old Kingdom sites provide insight into how these grand monuments were built and financed. The Egyptian state commanded vast resources, utilizing agricultural surpluses and an organized labor force to construct these colossal structures. Archaeological evidence suggests a highly skilled workforce lived in designated villages near the pyramids, supported by extensive provisioning systems. Excavations have uncovered bread molds, fish remains, and tools indicating that thousands of workers were systematically fed and housed. Officials carefully managed their rations, work rotations, and craftsmanship, ensuring precision in the pyramid's construction. Beyond their architectural brilliance, the pyramids held deep religious significance. Egyptians viewed them as spiritual gateways, allowing the deceased pharaohs to ascend to the realm of the gods. The internal chambers, passageways, and burial rooms were meticulously arranged for funerary rituals and the safekeeping of burial goods. Hieroglyphic inscriptions reference prayers, offerings, and the afterlife, further emphasizing their sacred role. Priests continued to maintain these temple complexes long after the pharaohs' deaths. Over centuries, much of the Great Pyramid's original polished limestone casing was stripped away, leaving the rougher core we see today. Many adjacent temples and causeways also suffered from stone repurposing and natural erosion. Yet enough evidence remains for archaeologists to reconstruct how these complexes once appeared, revealing a carefully planned landscape where pathways from the Nile led directly to these funerary monuments. A hidden dimension beneath Giza. For years, archaeologists believed that Giza's subterranean features were relatively limited. They had identified short tunnels beneath the pyramids, some leading to chamber complexes and smaller burial shafts. Additionally, rock-cut tombs on the plateau's outskirts indicated a tradition of carving into limestone. However, the prevailing belief was that the site's architectural genius lay primarily in its towering above-ground structures. Recent scientific advancements have changed this perspective. New discoveries indicate that the Great Pyramid's subterranean landscape is far more extensive than previously thought. The identification of deep wells and massive underground stone blocks has forced researchers to reconsider the construction capabilities of the Old Kingdom. For centuries, historical records described simple construction tools, copper chisels, flint blades, dolerite pounding stones, and wooden sleds, as the primary means by which the pyramids were built. Archaeological findings have consistently reinforced this narrative. However, evidence of deeper underground structures suggests that specialized tunneling techniques and advanced stone-cutting skills may have played a crucial role in shaping these vast subterranean spaces. Cutting-edge technology unlocks ancient secrets. Archaeological research has traditionally relied on excavation, epigraphy, the study of inscriptions, and architectural comparisons. While these methods remain invaluable, they are limited when investigating solid, massive structures like the pyramids. The need to explore hidden features without damaging cultural heritage has driven the adoption of non-invasive imaging technologies. One breakthrough in this field is radar Doppler tomography. Traditional ground-penetrating radar, GPR, sends electromagnetic waves into the ground and detects reflections. But Doppler-based techniques go further by analyzing minor environmental oscillations, such as microseismic tremors. These methods provide highly detailed insights into underground structures. At Giza, this technology has been instrumental in detecting well-like formations hidden beneath layers of limestone. Previous generations of radar equipment struggled to penetrate the thick limestone of the plateau. However, Doppler tomography capitalizes on natural Earth vibrations to enhance detection capabilities. As microvibrations travel through rock, they interact with different densities, allowing researchers to identify hidden cavities or constructed spaces. Sophisticated software then processes this data, generating 3D images of the underground environment. Through this method, researchers have identified deep cylindrical wells beneath the Great Pyramid, each with a consistent circular cross-section. Early scans revealed at least 8 such wells arranged in parallel rows, with some featuring spiral pathways along their inner walls. Unlike natural fissures, which form irregularly, these wells exhibit geometric precision, confirming their artificial origins. Further analysis has shown that these wells extend vertically to significant depths, prompting new questions about their original purpose. Were they part of an ancient subterranean system designed for unknown functions? Did they serve a structural role in the pyramid's construction? Or could they be evidence of a lost technological capability that allowed the ancients to achieve feats far beyond our previous understanding? A new era of discovery. As research continues, these findings challenge long-held assumptions about the Giza Plateau. With advanced imaging tools providing unprecedented access to hidden structures, we may be on the brink of uncovering the true extent of the pyramid's mysteries. Whether these underground features served a ritualistic, structural, or even technological function remains an open question. One thing is certain, the Great Pyramids of Giza are more than just monuments of the past. They remain active sites of discovery, pushing the boundaries of what we know about ancient civilizations. As modern technology peels back layers of history, we move closer to understanding whether these structures were simply royal tombs or something far more extraordinary. As the wells approach a depth of around 600 meters, their exact endpoints show slight variations influenced by the underlying bedrock contours. These wells appear to be integrated with massive stone blocks which are cubic in shape, measuring approximately 80 meters across. The tomographic images reveal edges and angles that significantly differ from natural rock formations, indicating that these solid blocks are aligned with the ends of the wells, suggesting they are capped or supported by these geometric structures. Some sections of the data highlight the presence of a spiral ramp or path that ascends along the interior walls of the wells, marked by subtle density changes. The ramp's continuous nature implies it may have provided access between different depths, facilitating the movement of supplies, groundwater collection, or ritual activities. These wells and blocks are not random geological features but appear to form a cohesive layout that corresponds with the pyramid's geometric design above ground. Analysts have observed that the wells align with key corners or edges of the pyramid's foundation, suggesting they may function as load-bearing or stabilizing pillars. Their cylindrical form, coupled with the large cubic bases, likely serves to distribute the weight of the entire pyramid structure. This underground engineering technique surpasses conventional bedrock leveling seen in other Egyptian pyramids. Moreover, the apparent spiral path suggests the wells had purposes beyond foundation stabilization. The ramp may have been used for descending to gather resources or conduct ceremonial tasks, possibly linking to early Egyptian texts describing deep underworld paths. These wells are far more than simple pits or tomb chambers. They are integral to the pyramid complex's engineering. Further scans reveal horizontal corridors at varying depths, which may link the wells to one another or to other subterranean elements. When these findings are cross-referenced with surface features, experts suggest that these substructures likely extend beyond the immediate pyramid perimeter. Scans of nearby areas and the discovery of surface structures show patterns leading toward the other 2 main pyramids at Giza, indicating a broader subterranean network. Although mapping is still ongoing, the consistent patterns across multiple perspectives suggest an expansive underground environment beneath the plateau. The public has long been intrigued by the idea of hidden chambers near or beneath the pyramids, fueled by ancient travel writings and medieval Arab chroniclers who spoke of labyrinths or secret stores of knowledge concealed in the bedrock. Though many of these accounts lacked concrete details, they contributed to the notion of Giza as a place where surface monuments might conceal a grander hidden realm. While early archaeologists uncovered small tunnels and burial shafts, these discoveries did not match the expansive networks described in legends. The recent confirmation of deep vertical wells and large underground blocks has revived interest in whether additional passages or chambers exist, aligning with historical descriptions of vast hidden spaces. Modern radar tomography data now provides tangible evidence of these hidden chambers, suggesting the potential existence of side rooms or branching corridors that mirror ancient practices of embedding corridors for funerary or practical purposes. These findings lend credibility to the idea that ancient accounts of hidden vaults may have real-world counterparts yet to be fully mapped. Egyptian civilization, especially during the pyramid-building era, was deeply focused on safeguarding crucial spiritual and material elements for the afterlife. The discovery of sealed corridors, deep wells, or hidden compartments aligns with this cultural drive to enclose and protect essential items for the pharaoh's eternal journey. While many past theories were speculative, modern scanning techniques now provide concrete data.